Evening, I'm Spot On Weather, meteorologist Matthew Euler. Welcome to tonight's video, Friday night video here on the 9th of December 2022. I hope everyone out there is having a great Friday and a very great holiday season as we get closer and closer to the Christmas holiday. Alright, so let's start tonight's video by taking a look at some of the upper level charts, the 500 millibar geopotential heights, which are in decameters, as well as the anomalies, which are in meters on these charts. The way I divided these up is on the left side, we are looking at, generally we're looking at the European Ensemble Prediction Center on each of the slides I'm about to show you. That'll be on the left side. And on the right side, I'll be showing you the 500 millibar geopotential heights and anomalies. This is the Jeff's model on the right. So European Ensemble on the left and the GFS Ensemble on the right. So this, by the way, this model data is as of the 12Z model run today on the 9th of December 2022. And wow, today's midday runs are really interesting, and I'm going to go ahead and delve deeper into that now. We'll start it off first with this Saturday, tomorrow, the 10th of December 2022, and what's going on. All right, so what we have going on, purple coloring indicating lower than normal heights, and then the brownish shading and these brighter oranges indicating above normal, higher than normal heights. Higher than normal heights are typically associated with upper level ridges, which generally produce milder surface temperatures as well as dry conditions. Whereas wherever you see these purple colorings associated with troughs, that generally equates to more unsettled weather and colder temperatures. All right, so for tomorrow, what are we looking at here? European EPS here on the left, showing a little bit of weak ridging building into the eastern seaboard tomorrow. Some of the major features or players that we see for tomorrow is a very strong upper level ridge extending from southwest to northeast toward the Aleutian Islands there of Alaska. We have a downstream trough from that here off the Pacific Northwest coast, indicated by this blue coloring here. And then downstream of that, we have a little bit of ridging across the eastern Montana area down into eastern Wyoming. A little bit of a weaker trough setting up over Minnesota, and then a much stronger ridge there extending associated with that negative NAO, extending generally into parts of northeastern Canada, and then an upper level height center over Greenland itself. Above normal heights, generally up over the Greenland area, indicative of that negative North Atlantic oscillation. We do have a fairly closed, deep area of lower pressure, a closed low at 500 millibars there over the northwestern Atlantic Ocean as well, with a trough extending southward from that. So in general, tomorrow, eastern U.S., European ensemble model here on the left showing weak ridging. The GFS, very similar with that, with general weak ridging across the Ohio River Valley, extending eastward to the eastern seaboard. The upper level trough just generally off the Pacific Northwest coast, and another major upper level ridge again, extending into the Aleutian Islands. And there again is our negative NAO situation over Greenland with that anomalously high heights. Now, what happens between tomorrow, Saturday the 10th of December, and early this next week coming up? This is where things get interesting. All right, a couple days ago on these model runs, it looked much milder. The ridge was much more established over the eastern U.S., generally throughout the week, from Monday to Wednesday actually. And now what you're seeing is more troughing. More troughing along the eastern seaboard. This is Monday, the 12th of December. By the way, this is a European model in both cases. This is the one slide. I just kept it completely European ensemble just to show you the general flow of things in the pattern at 500 millibars or 18,000 feet above the ground. So Monday morning, this is the 12th of December coming up. And then the graphic here on the right is Tuesday morning, the 13th of December. The major features. We got a lot of high latitude blocking going on, okay? We have a strong upper level ridge that's extending, the axis is extending from the southwest to northeast across the Gulf of Alaska. There's a little bit of troughing, and then you have another stronger upper level ridge still over that Aleutian Island area, extending a little bit further to the north into the Bering Sea. Downstream of these ridges, you have a fairly deep upper level trough at 500 millibars, extending into the California area and the U.S. Southwest. As this thing digs in, the ridge builds generally to the east of that deepening trough. So we have rising heights extending from Missouri northward to Minnesota, up and into Canada to the Hudson Bay area, and all the way across to Greenland. This upper level low, this closed low here around Nova Scotia on Monday, the 12th, with a trough extending generally down the east coast, it's allowing for colder air to just kind of infiltrate down the coast, really. And so this is a big difference here. Look over here on the right. This is the European EPS for Tuesday morning, the 13th of December. And now we see that closed low with the trough over the desert southwest, moves kind of pivoting to the east over northeastern Colorado with the lowest height center. And then out ahead of this troughing, again, you got that rising air downstream of the trough, extending from Alabama, working its way northward all the way up to Canada and into Greenland again. See this? See that brown shading? And look at all these maroon and brighter orange colorings extending back to this Pacific ridge. So we got pretty much blocking all the way across the top here, okay? Higher than normal heights across far northern latitudes, where we typically should see more in the way of lower heights. We're seeing anomalously higher heights. And then you see the upper level low by Tuesday just sitting there just to the north of Maine. But look at this cold trough. You see this blue shading here down the eastern seaboard? That's associated with that colder trough. So we got a squeeze play going on for the Midwest on Tuesday morning, where you see this ridge building. Milder temperatures generally in the Midwest. Now, one thing I want to mention about this pattern here down the East Coast, this is a pattern that's known as cold air damming. And what happens is colder air filters down the East Coast during a cold air damming situation, generally to the east of the Appalachian Mountains. I'm going to show you what that looks like here in a moment, more graphically, what cold air damming process is about. But generally what I'm seeing is that cold air damming situation. Cold air getting dammed up. It's so heavy, it's so dense, the cold air. It gets dammed up against the east side of the Appalachians. Because it's so heavy and dense, it can't be forced to go up and over the mountains because it wants to stay lower to the ground due to its density. One other thing that really is interesting is it's very difficult. When you get cold air damming down the East Coast, it's very difficult to scour that out, specifically this time of year in the month of December, where you have weaker solar radiation, lower sun angles, and you've got shorter day length, shorter amount of daylight hours. So it's much more difficult to really push this heavy, dense, cold air from moving out of the way with cold air damming this time of year east of the Appalachians. What's going to happen over time now? Here is the European EPS on the left. Here is the GFS Ensemble forecasting system on the right. And wow, things are changing big time here. This is Wednesday afternoon, next Wednesday, the 14th of December. And you'll notice this brown coloring here over northeastern Canada, all the way to Hudson Bay, extending back northeast towards Baffin Bay and Greenland. And there's another higher area of heights, generally in the Gulf of Alaska, another ridge at this point. Okay, we have a upper level low, closed low, fairly intense, which is positioned over the Dakotas with a trough extending southwest from that across Kansas, across the panhandle of Texas, right on down to eastern New Mexico. We have a pretty significant digging trough at this point. Now, east of that trough, we have a little bit of upper level ridging occurring along the East Coast by this Wednesday coming up, the 14th of December. If you look at the GFS Ensemble forecasting system on the right, big difference here now between the GFS Ensemble for next Wednesday, the 14th of December, and the European Ensemble on the left. If you look at this, the GEFs here on the right, see this? This is featuring lower, basically a stronger anomaly and lower heights off the west coast of the United States. The GEFS is. It's stronger with the troughing off the coast of Northern California as compared to the European Ensemble, where it isn't showing that kind of strong troughing. It's showing all that troughing being consolidated and further east on the European Ensemble. But on the GEFS, it has two pieces of energy. It has one closed low in a similar position as that European Ensemble, a little bit weaker. The trough is in the general same area across the southern plains, and then it has a stronger area of lower heights off the west coast of Northern California. But this feature at the top is the same. See this? Very similar positioning of the upper level heights, the higher heights here over Hudson Bay and extending back over the Gulf of Alaska in both cases, both ensembles here, okay? So what is this kind of pattern going to do when you have a block over the top like this? Okay, from Alaska, the Pacific side, all the way to the North Atlantic side to southern Greenland, we have a blocking feature in effect. What does that do? All right, this blocking look over the top from Alaska to Greenland is generally going to keep the storm systems from recurving to the northeast. You'll notice a lot of times in winter, what will happen is these storms will form in eastern Colorado or maybe the panhandle of Texas or Oklahoma, and they'll work their way northeast towards the Midwest and the Ohio Valley. With this kind of blocking over the top, these storms are now just going to basically work their way from west to east across the U.S., right? Because what is it? What is it that really makes these storms go west to east? These higher heights over the top to the north, these storms going west to east, that's caused by the fact that low pressure systems tend to follow the path of least resistance, okay? So they tend to want to they want to avoid higher heights or higher pressure areas. They don't want to go that way. That's like uphill to them, to low pressure systems. They go to the path of least resistance, which is lower pressure paths. Well, look what's going on here over the U.S. across the mid-latitudes. We have lower heights. The lower pressure paths are here. So you're not going to get a lot of recurvature of the storms in the northeast. What does that mean for the East Coast? Well, if we don't get those recurving storms over the Midwest, we will not get a strong southerly fetch of winds ahead of those low pressure systems, which means we're not going to have a super big warm up ahead of this system. Okay, it's going to be milder, yes, but it's not going to be a super huge warm up that you would get if this storm system were to move southwest to northeast, let's say from Oklahoma City to Chicago. You're going to get a much stronger fetch of warmer air, southerly and southwesterly winds ahead of that storm system in that case, that kind of track of a storm. But going west to east, because of this block over the top, the path of least resistance is west to east in this case, seeking out areas of lower pressure paths, not higher pressure paths or higher heights. Just wanted to throw that out there. Now, what happens? This is where things really, really get interesting. This is kind of like, that last, bit of milder air associated with the weak ridging next Wednesday, the 14th of December. But then by the time we get to Friday, the 16th of December, 1 week from today, 7 days from now, we still have this amazing blocking over the top into Canada, stretching from Alaska all the way to Greenland. Look at this. The brown coloring, the maroon coloring. This is quite an impressive pattern. Why is it impressive? Because it's anomalous. Not normally supposed to happen this way. We're supposed to have lower heights and coldest temperatures up here, but they're actually higher heights and warmer temperatures up here. What that does typically, it forces the colder air south along with those lower pressure systems and the troughs. And so what we have, the European EPS here on the left for next Friday morning, and this is the GFS ensemble on the right for next Friday morning, the green coloring indicating that those deeper troughs or those lower than normal height anomalies, the European EPS has a fairly decent sized trough across the eastern US by next Friday morning. The pattern is now changed to where we get a trough-like feature into the eastern U.S. This was once an area that was dominated by an upper level ridge and milder temperatures. It's now being changed out, the pattern, to more of lower than normal heights, indicated by the green coloring, and lower than normal heights in the atmosphere usually equate to a more compact atmosphere and one at which we have colder surface temperatures. All right, so big difference here between these two models. You can see it again here in the JEFs. The tendency for the JEFs to carve out a trough off the coast of California. And look at the strength of this trough according to the European EPS next Friday morning, the 16th of December. Not nearly as strong as this troughing here on the JEFs. So the JEFs is really strengthening the troughs a little bit more than the European ensemble prediction system here. But this is the key pattern. This ridge is starting to build now into the Gulf of Alaska, starting to get stronger here. And we got the block over the top. We still have a deep area of low pressure, by the way, over the North Atlantic. It's having a hard time exiting because of the higher heights to its north. So a trough is set up by next Friday, the 16th of December, along the eastern seaboard with colder temps, lower heights. The blocking remains in place from Alaska to Greenland, very key. Again, that means none of these, if any of these storm systems form here in the mid latitudes of the U.S. are going to be unable to curve to the northeast. They're not going to seek out these higher heights. They're going to seek out the lower heights, the lower areas, the paths of least resistance. Now, I told you that I was going to show you what a cold air damming situation looks like this is coming up early next week on the 12th and 13th of December. And here's a great graphic here which shows you the synoptic setup. So what we have typically is we have an area of high pressure over eastern Canada with clockwise flow around it. That's going to bring down cold, dry air down the east coast. Here are the Appalachian Mountains. They're in the eastern U.S. And as this clockwise flow of colder, drier air works its way from New York State right on down through D.C. all the way down to Virginia, sometimes this colder air at the surface is so heavy and dense it makes it all the way down to northeastern Georgia. Okay, but in general, what happens is this cold, dense air, it gets banked up against these Appalachian Mountains, and the cold air remains in place for a decent amount of time, especially in December, like I mentioned earlier. And one big thing about this is models tend to have a very hard time resolving when the colder air will recede. Sometimes the models don't depict it being cold enough, so they have a little bit of difficulty in determining what the temperatures are going to be and how long the duration of that colder temperature. All right, you have the Gulf Stream, by the way, that the warm ocean current offshore. And then what happens with time is sometimes you get this overrunning precipitation that sets up. This warmer, moist air, basically in the middle and upper levels of the atmosphere, it overruns this colder, denser air at the surface across the mid-Atlantic. And sometimes that sets up some precipitation. Sometimes it starts as wintry precipitation, actually, before the planetary boundary layer, the troposphere, warms the lower levels of it. All right, so this is the general setup for a cold air damming event. Now, this is a past example. What I wanted to show you was the signature of these solid black lines on this graphic in the upper right. That's associated, these solid black lines, each line represents a pressure reading. These black lines represent isobars, or lines of equal barometric pressure at the surface. What I want you to note is how these isobars kind of bend. See this bending right here? Specifically across Virginia in this example, working that bending of the isobars or kinking of the isobars occurs all the way down the east coast, down into South Carolina. This is just showing that colder air and the higher pressure associated with the colder air moving towards the south, right along the east coast. Here is the temperature anomaly forecast, by the way, here in the center here, bottom. Green and blue below normal, and then the maroon and the brown coloring above normal temperature departures. This is in degrees Fahrenheit. This is a European 2-meter temperature anomaly forecast for next Tuesday, 13th of December. Now look at the blue coloring here. See how the blue coloring extends from New York State down through Pennsylvania, New Jersey, D.C., Delaware, Virginia, all the way down the coast to North Carolina and South Carolina, even into parts of eastern Georgia. See this? We have below normal temperature readings associated with that cold air damming. And what's happening is there's a squeeze play going on right here in the central U.S. This warmer air is trying its best to work its way east, but because of this cold, dense, dry air at the surface associated with the cold air damming, it's having a very difficult time nudging that stubbornly cold air out of the way. So all that milder or above normal temperatures are confined to the central U.S. on Tuesday. Now, we do know some of this will eventually erode or scour out that cold air damming along the East Coast by Wednesday. But this is, real interesting stuff. We got a trough on the East Coast, we got a trough on the West Coast, over the western U.S., and we got this ridge, just this skinny little ridge, not very wide in longitude across the central U.S. by Tuesday. Let's continue to talk now about the forecast charts from today's midday model runs. Just unbelievable if you like winter weather. Here is the forecast now, European EPS, European Ensemble on the left, GFS Ensemble on the right. This is for Sunday, the 18th of December. Now look what's going on here. Look at the whole U.S. here. It's blue. This is European Ensemble on the left, a huge upper level ridge. It's strengthening, it's building, working its way northward into Alaska. And as this ridge builds, look at the downstream trough just deepening. We have cold air coast to coast, folks. The coldest or lowest height anomaly is going to be right along the east coast, out to the western Atlantic. We have a trough in place across the east. We got the ridge building across the Gulf of Alaska. and we have a negative NAO over the top here. See this? These higher heights into southern Greenland, Baffin Bay, working their way towards far northeastern Canada. This is just an unbelievable pattern here. Blocking all the way over the top. See the lighter orange coloring even between these major higher height centers? Just unbelievable. Cold coast to coast. The Jeffs right here on the right is in agreement generally again. But again, look what the Jeffs is doing here. It's deepening that trough again off the coast of California. So we're seeing that tendency of the GFS ensemble, the Jeffs, making these troughs deeper over the western U.S. than the European. And then look at the ridging here. On the GFS ensemble, the Jeffs, it's not as amplified or not as strong. The heights aren't as high on the Jeffs for the same time period. Next Sunday, the 18th of December. This is the upper air forecast for next Sunday, the 18th of December. Right, so overall, trough remains in place across the eastern U.S. That ridge is building in the Gulf. Again, negative NAO in place. Colder temperatures coast to coast by the 18th of December next Sunday. Now, let's move ahead. A few days forward in time. This is the winter solstice on 21 December, the first official day of winter in the Northern Hemisphere. And whoa. All right, I kind of switched the order here. I'm not sure why I did that. Yeah, I did. So I have the Jeffs for some reason on this slide on the left, and I have the European EPS or ensemble on the right. All right, if the European ensemble is correct, this is going to be a crazy good winter pattern if you want cold and snow in the eastern U.S. In the U.S. in general. I mean, this ridge is super amplified, okay? It's basically working its way, the ridge axis extending all the way up from the Gulf of Alaska into Alaska, even north of Alaska. We have the negative NAO. That's... Oh, wow. You know, this thing is like building again, too. This ridge over the North Atlantic side, over parts of Greenland, it's building as well. So I'm increasing my heights over the North Atlantic side. That would cause my NAO to go a little bit more negative. I've also got a super negative EPO, Eastern Pacific Oscillation, which is causing these heights, this ridge to build. And then the higher this thing builds, the deeper this trough gets. And now we could be talking about the development of cross-polar flow. Flow of very cold air directly from Siberia into Canada, into the United States by the 21st of December. This is a very distinct possibility at this point. You can see on the left here, the Jeffs, not nearly as strong with that upper level ridge over Alaska, not nearly as strong with the troughing over the northern plain states. If you notice that, right? Not nearly as strong either with the upper level ridge over Greenland, just the west of Greenland. European is stronger with that ridge. But this is what I'm really, really interested in. The positioning of this upper level ridge axis, okay? It doesn't matter which model I'm looking at here. They're fairly close in agreement on the 21st of December. If this what I've noticed is the upper level ridge here sliding to the east. Let's go back. Let's go back. Look where the upper level ridge axis is here on the 16th of December. It's further to the west. It extends north, the ridge axis, from the Gulf of Alaska into the western state of Alaska itself. But now look what happens by the 21st. This ridge axis is almost right immediately along that the west coast of North America, okay? It's getting very close to it. The orientation of it is becoming more south than north as well. The orientation of the axis. All right, the upper level ridge sliding east, very noticeable. The ridge axis approaching the sweet spot, as I call it, for colder temps in the eastern U.S. If this ridge axis, if this European is right, the ensemble, and this ridge axis goes a little bit further east, right along the immediate west coast of North America, from the Pacific Northwest up to the west coast of Canada, it is going to be extremely cold. There's going to be even colder air coming down. We are in that time of year now where, you know, we're climatologically favored to get colder temperatures, and boy, this one is going to have this one could be interesting, okay? And it's a case really of, I call musical ridges. I call it musical ridges. It's like musical chairs, right? Which one of these ridges is going to be more dominant? All right, we have seen that the negative NAO, the upper level ridge into Greenland, the blocking on that side, the Atlantic side, has been super strong. And now look what's happening on this European EPS. Now the ridge on the Northeast Pacific is becoming more dominant and the stronger of these two ridges. But regardless, you got a connection of the ridges over the top. from Alaska to Greenland. Look at this. And then you got a lobe of the polar vortex, which gets shoved south. All right, let's go back here. There's no indication on the 18th of December of that polar vortex lobe here. See the orange coloring? Orange coloring. Now look at this. Look at this. This lobe of the polar vortex is getting shoved south into central Canada, there in the shores, the western shores of Hudson Bay. That's what's going to bring that very cold air down if this occurs. Let's look at the temperature anomaly forecast. This is a European ensemble mean. All right, the upper left is the 13th of December. Middle top is 15 December. Top right is 18 December. Bottom left here is 20 December, and then the bottom right is the 24th of December, Christmas Eve. The browns and the maroon, the bright oranges, above normal temps. The green, the purples, the blues, below normal temps. So we start off with this Tuesday. A temperature anomaly forecast, the European ensemble mean, and look at this. That's an association with the upper level ridge. See this little skinny area of above normal temps from East Texas right straight north into central Canada. And then you got the colder than normal temps along the west coast, in the western U.S., and on the east coast. Troughing on the east coast, troughing on the west coast, ridge in the middle. There you go. The middle center here, top center, now I have signs of that cold air damming still remaining in place. On this particular model, it shows the cold air damming still lingering east of the Appalachians from Pennsylvania to Virginia on Thursday, 15th of December. As this weak transitory ridge tries to basically move in ahead of this colder air out to the west. And then the forecast upper right here, this would be for Sunday, the 18th of December. Oh, look at this purple coloring and the darker, the maroon and the darker purple coloring. Very cold, very cold. Dakotas west to Montana, eastern Washington, Oregon, and then cold and normal temps all the way down the Gulf Coast. This is when the pattern change is complete. It's cold coast to coast. And then bottom left here is the forecast for 20 December temperature anomalies. Still blue coast to coast. The coldest air remaining back in western Canada, as well as parts of the Dakotas, Montana. And the bottom right here is Christmas Eve. Cold all the way coast to coast again. What about the temperature anomaly forecast for the EPS control today? This was insane. Now, I know control is just one particular solution. It's not a whole variety of model numbers. I get it. But in general, I just want to show you the general patterns here. Same dates apply here on this slide as the previous slide, 13 December, top center 15 December, top right 18 December, bottom left 20 December, bottom right 24 December. Very similar solution. So cold air damming showing up again. If you notice here on Thursday, the 15th of December, the anomalies, the blue coloring from Pennsylvania south to Virginia. Very tough to scour that colder, denser air out and get it out of the way. And then over here on the top right, this is the 18th of December. These ensemble, the overall temperature anomaly forecast in agreement with all the different models. Colder than normal coast to coast. Look at the Gulf Coast on this one. Well below normal, including Florida, by Sunday the 18th of December. Bottom left, this is a cold, cold picture in the bottom left. These anomalies in purples are on the order of 9 to 11 degrees Celsius below normal. And then over here on the bottom right, Christmas Eve, some of that very cold air, a lobe of that very cold air kind of shifted to the East Coast by Christmas Eve, according to this model, EPS control, and very cold air across the western U.S. Here is the temperature anomaly forecast now from the GFS ensemble forecasting system, the GEFS. Again, very similar pattern here. Cold east, cold west, warm in the middle. And then this is on Tuesday, the 13th of December here. The top center graphic for temperature anomalies for the 15th of December, showing again the evidence that cold air damming still being stubborn to retreat. And the coldest air is generally west of Mississippi River on Thursday, the 15th of December, next Thursday. The top right here, 18 December, it's cold coast to coast. And then bottom left here was for 20 December, showing cold from coast to coast. So what are we talking about here? Whether we look at the EPS mean temperature anomalies, cold by the 18th of December. If we look at the EPS controlled temperature anomalies, colder temperatures moving in, below normal temps by 18 December. If we look at the GFS ensemble forecasting system, cold, 18 December. So it's going to be cold, cold, cold. All right. Additional model support for cold temp anomalies. Wow. This was a European control run today. Look at the temperature departures, how far below normal they are in some of these spots in the purple shading. Upper Midwest, 20 to 23 degrees Fahrenheit below normal. The green coloring is generally 8 to 11 degrees Fahrenheit below normal. Look at Florida down here, 20 degrees below normal by Monday, the 19th of December, according to the European operational model from today's midday run. And then look at this on the right. This is the NCEP, this is the GFS ensemble, temperature anomalies in degrees Celsius. Green to blue, colder than normal. And look at it across the whole U.S. by 19 December, coast to coast. Now let's take a look at the teleconnections forecast. Instead of doing that traditional teleconnections video tonight, I decided just to look at the long range again. And I will show you some of the key teleconnection forecasts in this video, starting with NAO, North Atlantic Oscillation. The EPS 50 perturb members on the left, and then the GFS ensemble forecasting system, Jeff's V12, 30 perturb members on the right. The green line represents the average of all the model members. That's your ensemble mean or ensemble average. NAO sharply negative, and then right after the 13th of December, it starts to climb up a little bit, starts to rise a little bit, and gets closer to this neutral line by the 20th of December. Looking at the GFS, Jeff's V12 here on the right, similar story, strongly negative through about the 13th of December, then starts climbing and rising a little bit. Leveled off a little bit here. It's a little bit of a difference from the Jeffs to the European ensemble. But generally between 16 and 18 December, it levels off. But then it gradually climbs again. But it still remains more negative, the Jeffs model, right on through Christmas, as compared to the European ensemble prediction system has that NAO creeping up closer to neutral. Watch the period really from 19 to 24 December for a potential East Coast storm, winter storm. As this NAO transitions closer to neutral in this window, 19 to 24. 19 to 24. Watch that window. The AO Arctic Oscillation Forecast, again, European EPS 50 perturb members left, and GFS V12, GFS Ensemble Forecasting System, Jeffs on the right, 30 perturb members, showing a very similar story. Generally, what we're looking at the European EPS is a strongly negative NAO associated with that blocking, and then a general climb to closer to neutral after basically right around the 20th of December. We look at the Jeff's V12 forecast on the right, very similar to the NAO, where it kind of levels off between the 16th and the 19th of December, and it remains negative the entire time, the AO. Similar to the Jeff's NAO forecast, negative the entire time. PNA forecast. Now, this one's been the bugger, right? This one's been the one that everybody's been talking about in social media, saying, if we could only get rid of the negative PNA, can we just get rid of it, please? Well, it looks like the models are trending that way. If you look at the EPS here on the left, you generally see that it's climbing from negative territory to more neutral territory by mid-month, by 15 December. The one thing with the European, though, ensemble prediction system, it kind of dips it back to slightly negative then, all the way to the 24th of December. Whereas the Jeff's V12 brings it generally close to neutral by the 14th of December, very similar as far as when it goes neutral. Neutral all the way to the 18th of December, and then kind of dips it slightly negative, but then back closer to neutral after the 21st of December. So there you go. What does this mean? European, the ensembles are indicating a much stronger ridge building into Alaska by the 21st of December. So it's going to be interesting to see if in the future runs here, if this PNA gets a little bit more positive. You can see the white line here on the control. It actually does show it on the European control going slightly positive here. That white line here, generally from the 16th to the 19th of December. So it'll be interesting to watch these trends in the coming days. Now, this one's a big one. Eastern Pacific Oscillation Forecast. I did not show this on the video 2 nights ago, but Look at how this big drop off, this green line, how it drops negative. 17 to 18 December, this thing is reaching peak negative value on the EPO forecast. And then it starts climbing a little bit, but still it's so far negative. It remains negative all the way to Christmas Eve. And then the Jeffs V12 here on the right, same story. Dropping significantly negative by mid-December and then just slowly climbing out of that hole, remaining negative the entire period through the 25th, through Christmas Day. So EPO, ooh boy, how negative this is, that really could play into how strong the upper level ridge becomes, that northeastern Pacific. That ridge really builds deep. That ridge really builds the way it's forecasted to on the European ensemble. Wow, we could have really cold air downstream of the ridge into the U.S. This is an example of a strongly negative EPO in the temperature anomalies. This is taken from late November. So this just occurred last month. Just wanted to show you, at this point the ridge was breaking down. All right, so this wasn't the peak intensity of the ridge right along the west coast of North America, over Canada into Alaska. This wasn't obviously the peak intensity of it on this particular upper level chart. But you can kind of see what happened here. When this upper level ridge built, it allowed cross-polar flow to develop. You're seeing that with this deep purple coloring here over eastern Canada and over Maine. This allowed extremely cold air to flow from Siberia, Arctic, Canada, right down to the eastern U.S. with that strongly negative EPO. These were the temperature anomalies for the 21st. Actually, this would be the evening of the 20th of November, Sunday the 20th of November, when we had that really cold surge of air over the eastern U.S. We're talking temperature anomalies in degrees Fahrenheit, anywhere from 10 to 15 degrees below normal along the East Coast, and over the Ohio Valley, 15 to 20 degrees Fahrenheit below normal. Even Texas got in on the act. So I'm just saying, if we get a very strongly negative EPO, as these models are forecasting here, and now we're in the month of December, we can have another round of extremely bitterly cold air that's going to work its way from west to east over time. So just something to really watch. Here are the sea surface temperature anomalies. I wanted to do a comparison of last year on this date, 2021, and then this year. All right, there's two things we can see that really stick out, right? We can see we have these below normal temperatures, this blue shading, over the eastern equatorial central Pacific associated with La Nina. Last year in 2021, on this date, we had much colder than normal temperatures in the Gulf of Alaska, water temperatures. And then we also had, these orange colorings. The brighter the orange coloring, the warmer the water temperatures are. You notice how more, warm the water was in general across the North Pacific and the North Atlantic last year. Look at this year. Yeah, you do see above normal water temperatures generally in the central North Pacific, okay? You do see a little bit of warmer than normal water off the coast of Japan. You do see warmer than normal water off the East Coast this year. But in general, to me, this year, it doesn't look, the anomalies look slightly cooler, the water temperatures in the North Atlantic and North Pacific. Last year at this date. Look at the MJO forecast now. Here is the GFS ensemble forecast from 9 to 23 December. The thicker green line represents the forecast, the average, the ensemble mean or average. That thinner green line represents week 2, by the way. The thicker green line is week 1. So you kind of see what's going on here. The inner smaller circle here, whenever the MJO is in this smaller inner circle, that generally indicates minimal impacts, a weaker magnitude of the MJO, something I refer to as a null phase. And so, we're looking at a general forecast of where the MJO stays minimal as far as impacts on U.S. weather. Not much magnitude to this MJO forecast. But we also can see that the convection is trying to develop over the Indian Ocean. That's phases 2 and 3 of the MJO. But right now, it's mainly the null phase. Now, if by chance we were to work out of the null phase into phases 1 and 2, look at the temperature anomalies of phase 1 and 2. It's still, phase 2 is pretty much cold coast to coast, as well as phase 1 outside of Texas and New Mexico. But in general, phase 1 and phase 2 is a colder situation for the eastern U.S. You get into phase 3, things start getting a little bit more mild. See this? If this were to get stronger magnitude into phase 3, if you get into 4 and 5, the maritime continent, oh boy, things get really warm in the month of December. If you get MJO phases 4 and 5, okay? Here are my final thoughts on tonight's video. There's so much to cover. Looking at these midday runs today, the model runs, it's phenomenal. Today's weather charts are just showing more robust cold signals, period. Colder temperatures are coming east eventually, okay? Widespread coast-to-coast cold is definitely in the cards. In the short term, what we're expecting is that cold air damming the CAD, that wedge, to set up along the East Coast with below normal temperatures for both Monday, 12 December and Tuesday, 13 December. And I kind of showed you what that reflection looked like on the charts today. Go back. All right. Here's that cold air wedging, okay? You see it extending from this closed upper level low over eastern Canada, working its way southward down the East Coast, that blue coloring here. So we have that cold air damming in place initially. We'll have the upper level ridge. It looks weaker now than past days as far as the 14th of December, Wednesday. And, not as strong. That's eventually going to give way, that ridge, though, to troughing in colder temps by 16 December, next Friday, 1 week from today. That sharply negative EPO, Eastern Pacific Oscillation, very similar to late November, and I showed you that. I showed you what it looks like. Look at the forecast here, the green line, how much it dips in the negative territory on both the European EPS and the JEFs. And look at what happened in late November when we have a similar situation with the EPO. Wow. Now we do have a little bit of difference now. That's at negative NAO. So a negative EPO plus a negative NAO would definitely be favoring colder temperatures in the United States. And so that's really interesting. And the stronger that EPO goes negative, the greater that EPO goes negative, this is going to allow the upper level ridge across the Northeast Pacific to build to higher heights into Alaska. And if that ridge axis shifts just a little bit further east, this here, by the 21st of December, if this thing shifts just a little bit further east, so right along the immediate coast here, look out. That trough's going to be further to the east, and that very cold air is going to get all the way to the East Coast. But we will have to watch this, the MJO. Because if this were to come out into phase 3 and 4, the MJO would work against the cold signals we're seeing now. Overall, the negative NAO and the block over the top remains in place. And that's going to allow for longer duration colder temperatures in the U.S. And honestly, looking at today's charts, this could mean a colder Christmas this year for many. We're not used to that. Past few years have been fairly mild at Christmas. And then finally, the negative NAO and negative EPO combo. It looks to allow for resurgence of colder air to filter in from Canada by the 21st of December. And that should last right on through the Christmas holiday. We are watching the upper ridge axis again, as I mentioned, over the Northeast Pacific. If that ridge axis positions itself over the west coast of North America, it definitely will be much colder across the east in late December. It's just a matter of where the ridge axis sets up. I did a video a few videos ago. I titled that video Location, because it really matters where these different synoptic scale features set up as far as the sensible weather goes. Now, will the storm track be active? I haven't really talked a lot about storms, right? Tonight's video. Let's go back here. I just want to talk about this. Okay. All right. So where does the baroclinic zone set up? I'm always talking about a baroclinic zone. That baroclinic zone is that boundary between very cold air and milder air. And that temperature contrast is really what storms tap into to get stronger. If you have a baroclinic zone, let's say located from just off the southeast coast and extends west to east, generally across the deep south, if that's where your baroclinic zone is, that means your colder air has moved further south. That means your clash of air masses is further south. That's going to set up a storm track further south. With the blocking over the top, again, that will not allow these storms to recurve as easily. Okay? So, really, where does the baroclinic zone set up? It's going to be dependent on the upper air pattern and where the ridge axis sets up, where the trough axis sets up, and it's all connected. There's been indications, specifically in yesterday's model runs, that we could see a more active storm track setting up. But really, today, I'm not seeing such a strong signal for storm activity. Seeing more in the way of colder and drier air masses coming in from the northwest all the way to the east coast. I'm not seeing as much storm activity, but that could change. Really remains to be seen, but certainly this is a favorable pattern to promote more suppressed southern storm track with snow and ice potential much further south than we normally would think for this time of year based on climatology. The block over the top, the upper level ridging and higher heights at the higher latitudes, as I mentioned, it's not going to allow storm systems to easily curve to the northeast or poleward. So that's going to favor more of a west to east track. So, I've been watching and learning. They say that wherever a storm comes in on the west coast, okay, where it enters on the west coast, whatever latitude that is, it generally tends to exit the east coast at the same latitude. So let's say a storm comes in around San Francisco, around 37 degrees north latitude. It's generally probably going to exit in the vicinity of Norfolk, Virginia, okay, off the east coast. If I were to draw a straight horizontal line across as far as latitude from San Francisco to Norfolk, that's generally the rule of thumb. Where a storm comes on shore on the west coast is usually where it exits at the same latitude on the east coast. I find that real interesting. It's a real interesting rule of thumb. Right, so potential is there, which I find really astounding, this last bullet. The potential is there for renewed strengthening of the NAO, the North Atlantic blocking, a more negative NAO late December. It doesn't really appear like this high latitude blocking really plans to go away anytime soon. Whether we're talking the Northeast Pacific Ridge or the North Atlantic Ridge, it just seems like the high latitude blocking is really, really a prevalent theme over the next 2 weeks right now, and could potentially extend all the way into January, especially on the Atlantic side with a negative NAO. This is really interesting. Right now, it's honestly, looking at today's ensembles, looks like a case of musical chairs, or I call it musical ridges, how they're switching from the North Atlantic side being more intense and dominant, and then it switches over to the North Pacific side. And now is it going to switch back to the North Atlantic side? Is it going through a cycle to where the North Atlantic Ridge is more dominant and is stronger, has higher heights than the Northeast Pacific Ridge? That then takes over and goes back to the North Atlantic Ridge. Are they going back and forth? Either way you cut this, blocking the higher latitudes generally favors colder temperatures and lower heights in the lower latitudes and the mid latitudes, specifically where we live. So this is really interesting weather pattern. I'm really excited about it. I wanted to make a quick video tonight to kind of talk about these and how everything's coming together. Very good model agreement at this point in time. One of the things I honestly could see happening in the longer range here, the cold pattern looks to set in by the 18th of December. Okay. Or actually 16 December rather. The cold pattern settles in the east on 16 December. What I can see happening is like just these little lobes of colder air kind of moving across the country, or maybe you get some reinforcing shouts of colder air from Canada in this kind of situation, to where you get extremely cold weather in the east, and then that kind of moves off, and that trough, it was once very deep. Let's say it just kind of like flattens out a little bit more, and then we see another resurging area of colder air coming in from Canada. So we might see like just multiple rounds of cold weather reinforcing shots from Canada with this kind of scenario, this kind of upper air pattern. Or, do we see just cold coast to coast persistent weather? That's really the two options I see right now, is reinforcing shots of cold air every 2 to 3 days in the east, or just persistent cold coast to coast, west to east coast. So there's a lot to really talk about, and I greatly appreciate everybody's subscription to this channel. I hope you learn a lot in the process of me talking through the weather with you. That's all I got for now, everybody. We'll be keeping a close eye on this potential wintry weather pattern across good chunk of the U.S. as we head towards the Christmas holiday. And we'll be watching to see, too, if we get a more active southern storm track. Do we get storms come off the southeast coast with colder air to the north? That could set up some wintry weather for sure. All right, that wraps things up tonight. Everybody, until next time, take care and God bless.